Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. So in this video, I'm going to teach you on example about the minimization or maximization problem, okay, where we want to try the problem by using the linear programming model. So this is what we call it as the linear programming problems. All right. So let's take a look at the example one. Okay. The Lawrence Shortop Company manufactures two lines of bathtub. Manufactures two lines of bathtub called Model A and Model B. So there are the two Model A and Model B. Every tub requires blending a certain amount of steel and zinc. Other resources, steel and zinc. Okay, so that are the resources. The company has available a total of 25,000 of steel and 6,000 of zinc. Okay, each model a bathtub requires a mixture of 1 to 5 of steel and 20 of zinc, and each yields a profit of 90. Ini untuk model A. Okay, for model B, requires 100 of steel and 30 of zinc and can be sold for a profit of 70. Find by graphical linear programming the best production mix of bathtub. The best production. So this is the maximization problem. Okay, you need to remember that previously during class, okay, I've told you about how to setting up our linear programming model. The first one, you must have the objective function and you know your decision variables. Okay, objective function subject to all the constraints. Okay, and then do not forget to write down your non-negative constraint here. Okay, so first, you want to maximize, okay, kita kata apa, the best production mix of bathtub. Okay, so we want to maximize the bathtub. How many type of bathtub that we have? Two, which is A and B. Okay, so the profit each, we want to maximize the profit, okay, of production of bathtub A and bathtub B. So for bathtub A, okay, the profit is 90. Okay, and bathtub B, the profit is 70. So we can write down here as maximization problem. We want to maximize the 90 of A plus what? 70 of B. Okay, and then subject to. Okay, we have subject to. This is the previous question. This is the solution of our current problem. Okay, subject to. So here are the constraints. So what are constraints that we have here? Kita ada apa lagi? We have the resources are steel and zinc, right? So probably the first line of your constraint is about steel. The second line of your problem is about the zinc. Okay, so for steel, for model A, it requires berapa zinc? Okay, 1 to 5. So the first one katakan kita kata steel So 1 to 5. 1 to 5 of model A of steel. The first one is constraint steel. And then for B, 100 of steel plus 100 of steel. Okay, for B. And dia punya restriction dia berapa? Oh, the restriction kita kata apa? Kita kata the available resources that they have for steel is 25,000. So less than or equals to 25,000. Okay, the second one is for the zinc. Model A, zinc. Model A, we have 6,000. So 6,000 of A. Okay, untuk zinc. Betul ke 6,000? Sorry, this one is no. Okay, model A, 20 of zinc. So 20 zinc A plus, okay, untuk zinc B, for zinc B is 30 zinc B and limited to 6,000. So 6,000. Okay, so we have setting up our constraint, and do not forget to write down our non-negative constraint which is A, B must be greater or equals to 0. So tulislah ni 1, 2 and the last one 3. So kita dah ada information. So now we want to solve. So this one maximize. So awak boleh letaklah maximize Z. Normally kita maximization or minimization problem we write down as Z. Z equals to 90A plus 100B. Sama kan macam kita buat tadi. Betul kan? Kenapa 100B? This one is 70. Find the this one is 70. This one is let me check first. Each model bathtub requires maybe 90 and 70. 90 and 70. So this one should be 90 and 70, guys. 90 and 70. Okay. So this one is correct. 125A plus 100B less than or equals to 25,000. 20A plus 30B less than or equals to 6,000. So let me check first. 2500, 25, 20A, 30. Okay. So this linear programming model is enough, sufficient enough, the information. So this one should be apa tadi? 70 kan? This one should be 70. So we go here is 70. 70 1 to 5. Apa benda saya betul kan ni? Betul dah. 1 to 500. 1 to 500. This one betul. The incorrect one is the objective function. This one lain. Okay. So now class, after we identify the kita kata apa after we identify the linear programming model, the second one is we need to graph it. Kita kena visualkan dia. How we can visual it? How we can plot the graph? Okay, so first of all, you have two constraints, right? This is the first one and this one is the second one. The first one and the second one. So consider the first one. Kita nak plot the graph ni. Nak plot graph. Okay, we want to plot the graph. So we have two variables A and B. Okay, so kita buat macam tu lah. Kalau X and Y, so X and Y. So now we have A and B. So sekarang ni class, when we want to plot the graph, consider the first equation first. So equation 1, dia kata 1 to 5A plus 100B equals to 25,000. So kita letaklah, when A equals to 0, so B saya 250. B, bila B saya pula kosong, A saya 200. Okay, so settle untuk equation 1. Saya pergi equation 2 pula. So saya plot dekat sini. 250. Somewhere here probably. 250. A 200, B kosong. Okay, sini. Contoh. So plot. This is the first constraint, the first line. The second one, consider the second equation. 20A plus 30B equals to 6,000. Bila A kosong, when A equals to 0, B equals to 200. When B equals to 0, A equals to 300. So you plot the graph lah. For another constraint. Okay. So saya dah plot dekat sini. Let's say I got this kind of graph. Okay, visual. I try to visualize the what we call it as the graphical of your linear programming based on your constraint. Okay, saya katakanlah this one is equation 1 and this one is your 2. Okay, constraint 1 and constraint 2. Okay. So now class, saya tengok balik tadi 250 equation 1, 250 equation 1, 200 A 200. Okay, so this one saya tak nak ni, saya nak follow macam mana yang kita buat tadi kan. So this one is my equation 1, this is my equation 2, which is referring to constraint 1 and constraint 2. Okay, lepas kita setting up our linear programming model, okay, mathematical equation. Okay, so next kita nak visual. So how we visual the graph? Macam mana kita plot the graph? By looking at our constraints. Kita ada dua constraints. Selesaikan satu persatu. Solve it one by one. Sebab kita nak dapatkan points. Okay, equation 1, constraint 1. Okay, we got this one. So plot. Constraint 2 or equation 2. Okay, when A equals to 0, you got B. When B equals to 0, you got A. Then you plot the graph. Then you have something like this. Okay, so now, after you plot the graph, you need to determine the feasible region. Okay, dah dapat dah feasible region kan? So kita nak tengok lah ni feasible region ni. Okay, so the question is now how to get the feasible region. As I said previously during class, the feasible region can be obtained by finding the region which is bounded by all the constraints that you have. Okay, so here you have two constraints. Okay, constraint 1 and constraint 2. So, di manakah feasible region tu? Okay, feasible region means that it is below the blue line and it is below the yellow line. So probably you can try to make it shaded. Okay, you try to shade the region. So probably let me try to draw it. Okay, some problem exists right now. Hopefully we can wait for a while. Okay. Alright, so try to okay. So we try to find the feasible region. The feasible region might be here, which is bounded by the two constraints, by the two lines. Okay, I can find the corner points of my feasible region. This is the point 1, this is the point 2, this is the point 3, and this is the point 4. Oh, I have 4 points. I have 4 corner points. Okay, I know that this is my feasible region. I noted this as F. So now, kita dah sketch the graph. Okay, we have already determined the decision variable. We already setting up our linear programming or mathematical formulation. We already visualize it through graphical representation. We already find the feasible region. Okay, so now how to find the optimal solution? Okay, how to find the optimal solution. So the problem is now, remember the maximization problem. Okay, we want to maximize the profit. Okay, so now we have two kinds of, we call it this, we have two methods available in order to find the optimal solution. The first one we call it as extreme or corner points method, and the second one is the isoprofit method. Okay, so now if we want to use the extreme or the corner points method, of course we need to find out what are the points in our feasible region. But before that, okay, let me try to duplicate the slide first. Okay, so first, let's say we want to solve the problem, or we want to find the optimal solution by using the corner points method. So in order to apply the corner points method, okay, so first of all, of course lah, you need to find out what are the points that you have. Okay, so the first point, okay, so probably I can write it here. Okay, the first point is obviously 0.00. This point is point 200, 0, and this point is 0 to 100, and the last point here is the intersection point. So when you have the intersection point, you need to determine the intersection points of these two lines. The intersection points of these two lines. Okay, so obviously you have two what we call it as two constraint. Okay, so I try to eliminate one variable so that I will have another variable. So if I'm not mistaken, okay, during my calculation I have this one 142.86. So I have this one is 142.68, and your y 142 is B, 142 is B. My A is 8571. Kenapa saya punya 8579 dekat sini 142 ni dia duduk atas. Macam pelik pula Macam dia tak, okay. So this is because of, probably because of my scaling. Okay, scaling saya ni mungkin tak betul kan. So in order to get this point, okay, in order to get this point, so first of all, you need to find the intersection point of this line and this line. So solve the equation simultaneously. If my calculation here is correct, okay, so means that the coordinate should be 8571. Okay, so 8571. Wait. 85.71 and just now is 142.86 ke? Okay, 142.86 86. Okay. So, after you get the 4 corner points, so kita buatlah, kita tabulate. Okay. So, this is the points. Okay, points, and this is the Z. Z just now. Apa masalah kita tadi? Apa what is our objective function? 90A plus 70B. So, this one is Z equals to 90A plus, ya Allah lupa, 90A plus 70B. Okay, plus 70B. So, this is our table lah. Okay, so this is our table. So, points we have 0, 0, and then we have points of 200, 0, and then we have 85.71, 142.86, and another one is 0, 200. Okay, so you must find out the optimal solution of Z here, maximize the profit. So, substitute 0, 0, A0, A0 and Y0 inside your objective function, you got 0. Substitute 200 inside here, what do you get? Okay, you get the value here. Okay, substitute 85.71 into A, 90 times this one plus 70 times this one, what do you get value here? And the last one is when A0 and your B is 200, so what do you get? So from this table, choose the highest Z, which is the highest profit. Okay, so that is gonna be your optimal solution. So that is how we get the optimal solution. Okay, faham? Okay, so that is the first method. The second method is that by using the isoprofit method. By using the isoprofit method, first of all, what you need to do is we need to rewrite our objective function 90A plus 70B. Maximize 90A plus 70B. 90A plus 70B. Okay, so this is our objective function, and then you need to modify, you need to determine, okay, what is the maximum profit that you want to get here. So probably I just write down here as 9 kali 7. Tak apalah. Okay, I set this as sekejap tak kisahlah kita letak berapa-berapa pun. Okay, for example, let's say I put this one as 1,000. Okay, 1,000. So now I want to find out another equation another line that represent my new objective function. Okay, by using my new objective function, saya nak dapatkan the points tau. Saya nak dapatkan points tu. Supaya saya dapat, so that I can introduce another line, another new line. So when A equals to 0, when A equals to 0, saya dapat apa? Macam tak cantik lah nombor ni. Okay, saya letak sini ni lah. This one equals to 5600. Okay, 9 kali 7. Okay, tu ke? Tak apalah, tak kisahlah, saya letak 56 lah. Ya, kalau kita boleh dapat the one number which is mudah untuk kita calculate. Benda macam susah. Betul lah, 9 ke 7, 63 lah. La ilaha Allah. Okay, so saya letak this one Okay. So when A 0, so that saya dapat berapa? So my B is 90. When B equals 0, my A gonna be 70. So dia tukar je, okay? Alright, so my coordinate here is 0, 90 and 70, 0. Okay, dekat mana titik ni ya? Okay, so let us see. Kita tengok. Titik 0, 90. 0, 90, x 0, this one is 90, is somewhere here. Okay, and then the second one is 70, 0. 70, 0 probably is somewhere here. Contoh lah ini Okay, so contoh macam tu. So saya dah dapat dah 2 points. So now I want to kita nak dapatkan garis dia. Okay, we want to find the line. Okay. So this is the lines, the new line of my objective function. So next is we move this ruler, okay, going upward because this is the maximization problem. So going upward, maintaining the slope tolak di atas, tolak lagi, tolak lagi. Okay, dah reach sini, 1 point of one corner point of our visible region, tapi ada lagi 2 points tak habis. Tolak lagi. Oh, dah jumpa 2. Tapi ada lagi another one. Tolak. Oh, this one is the last. This is the last point of our visible region. So this gonna be our optimal point. The question is, what is this point? Apakah titik ni tadi? Titik ni tadi adalah, kalau kita kira tadi by the intersection point, 85.71. Kalau saya tak salah kira lah 85.71 and 14286. 14286. So by using the, kita kata apa, isoprofit method, kita dah dapat the new line of our objective function. So kita tolak naik atas lagi. Okay, while maintaining the slope tadi kan. Okay, the last point of our feasible region is this point. So this point can be obtained by getting the intersection points of these two lines, this line and this line. So the intersection point is here. So how to get the optimal solution? Remember class, optimal solution, substitute back into your objective function. Objective function just now is we want to maximize. Okay, 90A, A is 85.71. Okay, plus 70B, 70B, 142.86. This value of 6,300 is no longer being used sebab dia sebenarnya tak adalah objective function pun. Okay, in order to apply the isopropyl method, you yourself just setting up the value. Okay, value yang kata apa make sense lah. Okay, so sekarang ni nak dapat jawapan dia yang betul, delete back your the equality here. So go back to the original one, 90A plus 70B, then substitute the point here, 85.71, and then 142.86. So you got the Z, your optimal solution. So that is our discussion on solving the linear programming by using true example, by using the isopropyl method as well as the corner points method. Okay, so now I want to show you another example. Okay, so now for this time, for this example, let me show you on how to use what we call it as programming tools. Okay, the programming tool that I want to share with you here is Tora. Later on saya akan tunjuk lah sekejap lagi. But if you do the assignment, probably you can simply apply the Excel. Okay, otherwise if you are type of you love challenges, probably you can apply Python. Okay, Python. Okay, macam tu ke je Python ke macam ni? Okay, this one. This is the correct spelling, Python. Okay, for linear programming. Or otherwise you can apply use Tora. I will show you the Tora after this, but let us check this kind of question. This is the previous final exam question, just to give you a vibe on how to solve this kind of problem. So let's check. The question is, Anna is making raspberry and chocolate cakes for a charity fair. Raspberry cake needs 200 of flour and 50 gram of sugar, while a chocolate cake needs 150 gram of flour and 250 gram of sugar. Okay, so the resources here, the resources mentioned here are the flour and the sugar. Of course, these two things gonna be our constraints. Okay, there are 3,000 gram of flour and 2,500 gram of sugar available. So this is the constraint or restriction. Okay, just macam apa saya cakap tadi. And then dia kata raspberry cake sells at 65 ringgit and the chocolate cake sells at 55 ringgit. So the question is, formulate a linear programming problem to determine the best possible combination of cakes in order to reach the maximum profit. So the problem is maximum profit. So how to do this? So first of all, kita kena tulis lah. Okay, so we want to maximize. Okay, we want to maximize the profit. Let's say the raspberry cake, we represent it as R, and the chocolate cake as C. Okay, so kita nak maximum profit kan, so kita pergi dekat bahagian selling ni. Raspberry is 65 and the chocolate cake is 55. So kita kata maximize, let's say Z. Maximize equals to 65 R plus 55 C. So that is our maximization problem. And then dia kata formulate all the constraints involved in this linear programming. The first constraint is the flour. The second constraint is the sugar. Okay. The first line is about the flour. Okay, kita kata the first line is about the flour. Kita tulislah subject to flour constraint. So we have apa tadi? 200 gram of flour to make the raspberry cake. Okay, and then another one is 3,000. Sorry, flour. Chocolate cake is 150. 150 chocolate cake. For chocolate cake, okay, and then the right hand side is for the restriction or the limited resources available. So for the flour is cannot be it cannot exceed more than 3,000. The second one is the sugar. Okay, the sugar is 50 R plus 250 C, and the limitation or the available resource for this one is 205,000. Sorry, 2,500. Okay. So the next thing is we need to setting up our non-negative constraint, which is R, and C must be greater or equals to 0. Okay, so next. Dia kata apa? What is the optimal solution to this problem? Solve it graphically. What is the optimal solution to this problem? Solve it graphically. So kita buat je lah macam tadi kan. Okay, so we have the first equation is 200R plus 150C equal. Okay, change this one to equal sign. 3,000. So this one is for the first one. When R equals to 0, C equals to 20. Okay, so the coordinate is 0, 20. Okay, when C equals to 0, so now our R equals to 15. Okay, so the coordinate here is 15, 0. Okay, R first, then C. Okay, so this one. This is R, this is C. Macam tu. Okay. This is our first constraint. The second constraint would be 50R plus 50R plus 250, C equals to 2,500. Okay. When R equals to 0, C equals to 10. When C equals to 0, R equals to 50. So the coordinate here is 0, 10 and 50, 0. R first and C. R at the x-axis, C at the y-axis. Okay, so that you can plot the graph. Okay, by plotting the graph, let's say you must plot the graph clearly. Okay, you try to plot the graph as have been taught in class previously. 020 is somewhere here, and 15, 0 is somewhere here. This is for the first constraint. Okay, the second constraint would be 010. 010 is somewhere here probably, and 50, 0 is somewhere here. There you go. Okay, so find the feasible region. So this is the feasible region. Okay, find the corner points. So we have 1, 2, 3, and 4 corner points. So now after we find out the feasible region and the corner points, so this is, there you go, we want to find out the optimal solution. In order to find the optimal solution, we have two methods. The first one is by using the extreme or corner points method, and the second one is by using the isoprofit method. So it is up to you nak guna yang mana. Okay, so kalau guna corner point, so obviously this one you need to find out what is this point. Okay, the intersection of two lines. Okay, so you dapat berapa lah kat sini. Okay, so by using either one of the two methods, okay, you got the solution. Okay, sebab dekat sini dia kata apa? Finally, dia kata based on your answer in C, calculate the profit. So how to get the profit? So you get the profit means that what is your optimal solution? Okay, optimal solution. So find your R and C, substitute back into your, we call it as objective function. So that is our total profit or the optimal solution. So next, let's try to plot it by using the mathematical program. So I try to share with you. Okay. All right. So this is the mathematical programming of linear programming by using Torah. So you can find out Torah on Google and try to download it. Okay, so this is the Torah. So just click and choose the linear programming. So this is very helpful when you do your assignment. Okay, so no need to calculate manually if you have two more than two constraints. So this is very easy. So click on enter new problem. Okay, decimal notation. So you just, you know that just now we have two constraints, right? We have two constraints and we have two variables. Okay, so we have two. Go to input screen and I name it as kick in in like, okay, so let's say this is the name. Number of variables, I have the variables just now is R and C. So of course this one is 2. And constraint is also 2 because I just have two line, two equation just now. So click enter first. After you click enter on your keyboard and finally dia keluar macam ni, it will appear input grid linear programming. So variable name, let's say the first one, kita kata apa? Kita kata this one is x1 is R, x2 is C, okay? So variable name kita kata this one is for okay. Okay, and this one is for another one. Okay, so according to our problem just now, we want to maximize the profit, right? So ini minimize, this one is maximize. So you just click here. Okay, this is the maximization problem. So I want to maximize the profit of raspberry is 65 and this one is 55. Okay, my constraint one is 200 of R, 200 of R, and the other one is 150C, and the restriction for the first constraint is 3000. Okay, what about the sugar of raspberry is 50, and for the chocolate one is 250, and this is lesser or equals to 2500, and the lower bound should be 0 and the upper bound is we can set to infinity. The unrestricted is no. Okay, so soft menu, click the soft menu and then do you wish to save the data? Yes. Okay, wait for a while and then find out our data just now. So the name is cake, right? Cake. Okay, so click the solve problem by graphical. So this one is it's okay. So check first, 65 R or x1 plus 55C which is x2. So 200 of R, which is 200 of x1 plus 150c, 150 x2 less or equals to 3000, and the second one is 50 to 4250 and 2500. Click here to graph LP in one stroke. Sekali je. So this method, for this one saya nak zoom in, zoom in. The blue line is your objective function. You see, OBJ here is the objective function that we can say that this one is by using the isoprofit method. Okay, because this objective function is actually dia move the line until you get the optimum point of your feasible region of your corner points here. Okay, so now by taking care of the end point, okay, of the optimal point here, okay, then we substitute back into our objective function, maximize z here, and then finally dia dapat the optimal solution of the objective value is 1026.47. So this gonna be the solution. So the things will be applied to your current problem. Okay, you have the assignment, and then you can try to analyze. You can try to prove it through Torah. Okay, so this is very simple and easy by using Torah, just focusing on the linear programming solution. Okay, so that is all for our lesson about the linear programming model. So all the best in doing your in doing and completing your assignment. So probably we can meet again during our class on Friday. Thank you, everyone.